Alright, welcome back everyone. Next we're going to talk about variables. So variables are something that are very important regardless of what programming language you are using. So the idea behind variables is they're sort of a storage container for data, right? So we talked about data types already, and those are sort of the nouns of our programs. Those are the things, the places, the names, the numbers, all the data that we want. If you want, you can store this data inside of a variable. The idea behind this is then you can use it multiple times without having to retype it each time. So in this example, we have two print statements. On the first line, we print north. North again is of type string. On the second line, we print north again, and then we also print Seattle. Another way you could write this exact same code, meaning it does the exact same thing, since here, as you can see, we're using north twice, the string north twice, you could instead store it into a variable and then refer to the variable instead. So in this example on the right, the variable that we're making, we're calling it location, and into the variable we are storing this string north. And then we print location, which is essentially saying, hey, print north. And then we print location, comma, Seattle, which is essentially saying, hey, print that string north, and then also Seattle. So again, variables are useful if you want to use a value multiple times in your code. So the way you want to think about variables, they are a storage location in your computer program, which again makes sense, right? We are storing our values into them so we can use them later. Every variable that you make, it's going to have a name and it's going to have a value. This value is specifically the value that it's holding. So in that previous example, location equals north. The name of the variable is location, so the name is whatever you type on the left-hand side. The value, whatever you're storing into it, in our example is north. And we've learned already that this value is of type string, right? We know that because it's a sequence of characters surrounded by quotation marks. So again, in this example, location is the variable name. The string north is the value stored in that variable. And again, that is type string. So again, this previous example, location equals north, this is what we call an assignment statement. So an assignment statement is a line of code that essentially stores a value into a variable. It's doing what we have just been doing on these past couple of slides. So one rule in Python is when you make a new variable, you have to give it a value right away. Meaning you have to use an assignment statement to make a variable. Alright, so here are two pieces of code. On one side we have location and then print location. On the right side we have location equals north. That is what we call an assignment statement. It has that equal sign, it has the name of the variable that we're making, and then it has the value north, which is of type string, which we are storing into our variable named location. Now, the code on the left-hand side, where it just says location, print location, that code is actually going to error. That will give us an error message because we didn't actually give location a value, right? So again, the rule is with variables, when you make a variable, you have to give it a value right away. Otherwise, you're going to run into error messages. So the code on the right-hand side, that's awesome. Location equals north, that's an assignment statement. That is assigning the value north, which is of type string, into our variable named location, and then printing that variable. So the code on the right-hand side is good. Code on the left-hand side is no good in Python. You always have to give a value using an assignment statement to a variable right away. Another interesting thing about variables is you can actually reassign variables to hold new values. So if later on in your code you want to give a variable that you have the same name for a new value, that's totally legal to do. You just have to be a little bit careful with that. So at any point in this example here, this code is printing location. So at that point when it says print location, it's going to use the most recently assigned value at that point. So when you read code, you want to read it top down, just like you would a book. So in this code, we have one line. The first line here is an assignment statement. We're making this variable name location. We're assigning this value type string, which is north, into our variable location. The next line is another assignment statement with the exact same variable. So that essentially replaces that string north with the string south in our variable storage location named location. That third line prints location. So it prints location up to the value that it has currently. Currently, it has the value south. So even though on the next line we say, hey, store the string central into location, because the print comes before that last assignment statement, this will still print south. So you have to sort of pay attention to the ordering, to the flow of your program. Everything reads top down. So if at any point you use a variable, you're going to use the most recently assigned value at that specific point in time. Alright, so there are some rules and conventions to naming variables. So in the past examples, I've been using a variable named location. You can name your variable almost whatever you want. There are some rules and some conventions, so let's talk about those now. So a couple of rules. Variable names have to start with a letter or an underscore character. And they can only have letters, numbers, or underscores. So do note that variable names cannot have spaces in them. Another thing to keep in mind, variable names are case sensitive, meaning a lowercase of the same letter is different from an uppercase version of that letter. So for example, volume with a lowercase v and volume with a capital V, those are two different variables. Those are two different storage containers. Another rule that we have about naming variables is that you're not supposed to use any of Python's special reserved words. Now, I realize at this point in time, we don't know a lot of reserved words yet, but that's okay. So just kind of keep that in mind. As we learn more and more of these reserved words, keep in mind that you should not use them for variable names. So for example, one of the reserved words we've already seen is print. That's a special built-in Python ability. So you should not use print as a name of one of your variables. Alright, here are some guidelines for naming variables. So these are things that you should be doing but won't cause your code to error if you don't do them. That said, I highly encourage you to get into the practice of following these guidelines now, because it's much harder to break a habit later down the road. Another thing to keep in mind as well is I will be reading your code, so I am actually grading on using good variable names. So please make sure you follow both the variable naming rules and these guidelines in your code for this class. So one of the most specific guidelines that will help you the most with avoiding using keywords that we talked about, like print, is to use a very descriptive name. So the more descriptive name you use, the more likely you will not hit one of those Python keywords, which is good. It also really helps the reader understand what exactly is going on in your code. So for example, if you want to store, say, a volume in your code into a variable, it's much better to use the variable name volume instead of just the letter V. So even though it's much easier to just type the letter V than to spell out the whole word volume, it is still much, much better to use descriptive variable names when you're writing variables in your code. Another guideline is generally you're going to use lowercase letters. There is a specific case where we will use capital letters, and we will talk about that next week. But generally when you're naming your variables, you want to stick to lowercase letters. And then we mentioned on the previous slide, you're not allowed to have spaces in your variable names. So the way you handle multiple words, so for example, miles per gallon, if that's a variable name that you're using, go ahead and use underscores to sort of represent where spaces would be. So again, with variable names, you want to use lowercase letters, you want to be as descriptive as possible, and you can use underscores to represent what normally would be a space character. So in that previous example we talked about, we saw a variable named location, and we stored a string such as north into it. So variables can store much more than just strings, and we'll talk about more examples of what other types variables can store as we talk about our more types throughout the class. Specifically, a variable in Python can hold any type, which is pretty cool. One other thing that I do want to point out about variables, let's go back to that location example. So here we have a couple things going on. Let's look at the first line of code. Location equals north. Again, that's an assignment statement. It is assigning this value north, which is of type string, into the variable named location. Now note that the variable location itself does not have quotes around it, right? I just typed out the word location. So the way Python knows the difference between a variable and a string is those quotes. So again, remember, strings you surround with quotes. Variable names do not have quotes around them. So be careful about that. Alright, I think potentially the most, not necessarily confusing, but the most maybe interesting thing about variables is if you use an assignment statement like this, x equals 5, now this is a poor variable name choice, right? You should not be using a variable named x in your code. But if you do an assignment statement like this, in your code, it's not exactly the same as saying x is equal to 5, right? So if you saw something like this in a math class, x equals 5, that would mean a couple things. That would mean x is equal to 5 and 5 is equal to x, right? It's an equality in a math class. In computer science, it's not quite an equality. So instead you want to think of it as a storage box that has 5 stored into it. So whenever I'm dealing with variables in code, I actually like to draw pictures to help me sort of keep track of what's going on. So my recommendation for doing that is, if we look again at this example, x equals 5, if we're treating that as if we're coming from Python, and this is some Python code here, again, the name of the variable is x, and the piece of data that we're storing into it is 5. So the name of the variable is on the left side, the data is on the right side. So again, in computer science, you want to think about these variables as storage boxes, storage locations in your program. So a way you can sort of draw that out is literally draw a box here, label it x, and then you can go ahead and say, hey, I put 5 into x. So this is how you want to think about variables in terms of computer science. Variables are storage locations, they're not equalities, right? Versus in math, if I wrote something like this, x equals 5, that also means 5 equals x. This is only in math though. This is not necessarily the case in computer science. So do keep that in mind. This line right here, slightly different in math than it is in computer science. So in computer science, this is an assignment statement. It's not an equality. So do keep that in mind. Another way to sort of illustrate what I'm talking about here with these equalities in math versus assignment statements in computer science, let's go ahead and look at these two lines, right? X equals 5, x equals x plus 1. So if we were in a math class, these two lines, these two equalities, wouldn't make any sense, right? Because it doesn't make sense to say, hey, x is equal to x plus 1. That doesn't make sense in a math class. There's no solution to that algebraic equation, right? Now, in computer science, if these are two lines of code, this is totally valid to do. All right, so again, that's another difference between math and computer science with these equations versus assignment statements. If we're treating them like equations in math, this doesn't make sense. If we are treating them like assignment statements in computer science, this is totally legal and valid to do. So again, the way you want to approach this is when you hit this second line, x equals x plus 1, what you want to do is you want to take everything on the right hand side and put it into the variable location on the left hand side. Now I realize we are doing some numerical stuff right now, and we're not quite talking about numerical types until next week, but just sort of humor me for now. So going back to this drawing that we did, this first line right here, x equals 5, if we're thinking like code, if we're thinking in computer science, this is an assignment statement. It stores this value 5 into this variable, this box labeled x. This next line right here, it's essentially saying, hey, take this thing on the right hand side, x plus 1. We look up what x is, and we see, all right, x is 5, so we get 5 plus 1. So this whole right-hand side gives us 6, right? That's the right-hand side of this assignment statement. X equals x plus 1. Do the right-hand side first. We get 6. And then put whatever the right side is into the left side. Again, the left side is the variable. That's the storage location. So at this point, you can go ahead and update this. You can go ahead and update this to now have the value 6 in it. So again, this is the computer science side. This is totally legal to do in computer science. These two lines of code, totally legal to do. Would not work in a math class. So again, the rule is with variables and assignment statements, you take whatever is on the right-hand side. If you need to do any calculations first, go ahead and do them. So in this example, we did x plus 1, right? So go ahead and do those calculations on the right-hand side, and then put whatever the result of that calculation is into the left-hand side, into that variable that is named x in this example. So again, think of variables as storage boxes, as storage containers.